I'm Janez Štebe from Social Science Data Archives from Slovenia. I'm working at the University of Ljubljana, Faculty of Social Science. I also have some teaching. So for today, I prepared something related to the FAIR principles, which I believe you heard already on the general level, but this is what we can apply those principles as social sciences. And we have two lectures. One is today, and today I will concentrate more on the data-related FAIR principles. And later on in the next lecture, I will also talk more about metadata-related principles. So just to repeat, FAIR principles, there are four acronyms for findable, accessible, interoperable, and reusable. And these principles are already around for some years, maybe 5-10 years. But there is increasing number of founders and institutions who require that researchers and students that they apply those principles. I would also like to kind of make you more comfortable when you are thinking about the FAIR principles, in a sense that maybe you don't need to know specifically what are those principles, but if you know like what is good data quality, and if you have good scientific practices, then you can also say that you're fulfilling most of those principles. And here are some maybe misunderstanding about FAIR. FAIR is not equal data quality, even if in general sense FAIR is about making that data more usable, and we can say that higher quality data, it attracts more use, it's more usable for different purposes, but it's not equal. FAIR is more a formal kind of quality that are contained. And also FAIR is not equal to open. You may discuss about FAIR in the context of open science, but when we talk about different objects, especially about data, we are talking about certain limitations. So we say that we want to have those data as open as possible and as close as necessary. And we will address later on some of the conditions that makes open sharing not feasible. And also reproducible is not reusable. So it's in the FAIR is reusable, but applying FAIR principles, you can achieve higher level of reproducibility as well, and you can then also follow this aim. And there are other principles that complement FAIR, like digital preservation principles. We won't go into the details of this, but this is also some good scientific practice also called for applying some digital preservation principles. And there are ethical principles which also encourage or demand that data sharing is a must. And maybe I mentioned care principles because care principles are also some principles that are more emphasizing ethical part, and that the data belongs to someone in social sciences, especially that someone was the data talks about someone, so they are in a sense also the owners of data, not only the researcher who collects this data. So as I said, if you follow this sound scientific practice in data creation, processing of data, you already cover much of the FAIR principles. And here are two quotes from some well-established researchers who try to emphasize that this data management, and especially this modern data management, is something that is falling to the skills that are needed for researchers. And we are now encountering different kind of data, new data, big data, social media data, and these challenges also need some data management skills. So there are some like trust and transparency also implied in FAIR principles. And regarding FAIR principles, and this is my last slide, mentioning FAIR principles as such. FAIR principles are actually, as I said, this is a elaboration that was published by a certain group some years ago, and it's not exactly clear what does it mean for a particular field or for particular data type, how to fulfill those principles. So here I listed only from one model, a data maturity model, I listed only a set of principles, and these are even not all of them, that apply to data. I said that the data and metadata are FAIR principles, and you can see that this is quite elaborated. It goes into the details, and we cannot mention all the details that are needed for fulfilling FAIR principles. But what I want to emphasize is that when we actually applying FAIR principles to social science, we need to know what are best or good practices in social science as such, because in those principles, it's many times it refers to community standards, and not all the disciplines have the same standards, and even those standards are not so established in each of the disciplines. So it's best to follow our disciplinary standards, and then we are on the safe ground. So here now I begin with those details, some of the details that relates to files and data structures that we meet in social sciences. And we can start with some file and directory names conventions that are there, or some advices about this. I hope this doesn't sound trivial, because I mean it's also some good housekeeping here contained, and I mean I can say for myself that I need many times to repeat what is this good housekeeping. So there are like different models for naming files, but some of the good models, and this is for example from some qualitative files, they actually are systematic in a sense that they contain different parts of the file name, separated by underscore, and you can imagine you have an interview that you record, so you have a file of recording, and then you have a transcript, and it's good that these two file names are just in one part the same, and in the part where they differ, they are different. So maybe the file format is different in this case. And I was asked also to mention if there are certain tools for maybe more advanced organization of different aspects of data management. And I find a reference here to certain tool. Maybe many of you may know it. It's actually general purpose bibliographic reference tool, Zotero. But here is some description, and you can go to the source to explore more description how you can use this Zotero tool actually to organize your files in directories and add some descriptions, and so you can then actually feel that while you doing the research, you also keep all the file naming, for example, strict and in order, so that you have a trace what you've been doing, what you collected, and so on. And I mean, these are just some advantages of systematic file naming. Like you can maybe when you change your computer or transfer files to some other location, you may need to also to rename the files, or you change the acronym of the project, or I don't know. So it's when you have this systematic file naming, you can like bulk convert. So you can select the whole file, the whole directory of files with the same name, but some extension you can just change this extension. For example, by using this command prompt of Windows, you can do this by some simple commands like rename, old name, new name, and this can save time. And also by having this systematic file naming, you actually can improve, enhance reproducibility, because then again, when you send the files and directories to some other destination, if they're arranged in a systematic way, so that, for example, the code or the syntax that use the file knows or have a name of the file in it, and if it uses this relative paths, you know that it's not a directory, a root directory name there, but it's just a relative relation between location of code file and data file. Then this reproducibility is preserved. You can run then the syntax on the same data as in your local environment. And we will talk about reproducibility also in the next lecture more. So this is, for example, a files and folder structure where there are files, and there, for example, you have in this example there is a script in R, and there is data, but in this more like as it's called executable compendium, it's one concept from computer science. You can have different versions of file also, like data clean, data raw, and also you can have a script for producing clean file, and then you have a script for R file, and then you have a results somewhere. And sometimes computer systems need an environment to be reproducible, so you have set like Docker file. This is all very advanced, and even I don't understand all the details of this, but this is just an example how you can structure the files and folders, and then you are also making this better in a sense of reproducibility, or if you will try to run your files next time, it will be easy for you. This is again an even more advanced approach. These are some of the colleagues from our Slovenian Institute for Biology who actually produced an environment for everything, like project descriptions, then study descriptions, then data files, then computer code, and so on. So this is just for you to, as a reference, something interesting can be there. Also used if you have a very complex project. Maybe you can use this tool also in social sciences. And well, we have some like we discussed a lot about quantitative, qualitative files and what are specific for qualitative files, and there are certain tools that are also used for those for the analysis and also for organizing data in the qualitative realm. And there is like a problem may occur if this computer-assisted qualitative data analysis software is used, but each of them has its own formats. Even if you export it, like it's only readable by the same product, and this is, I mean, it's problematic from different perspectives, but especially for sharing and archiving those files. If you want that someone else maybe will also use those files, then he would need to have a specific version of your software to read it. So there are certain solutions also there, like something is very practical and you can just export it from in the this the software specific format, but then you can also export it in like a human readable, as they say there, export files in like rich text format or PDF, Excel, and other widely used formats. So and because in the when you produce or code your qualitative data, you produce different parts like memos, and you have like code list and so on, and you can separately export all those parts. But there is also an interesting tool or initiative, this REFIUDA project, which actually do some nice things in ensuring that different formats and this computer analysis tools, that they talk between each other. So it actually enables conversion from one to another of those programs, and in that sense it also has interoperability, which is one of the important and word from FAIR principles. And you can see here there are many like Max, QDA, Atlas, NVivo, and so on. I know for those, but others are maybe are used in some other places. So these are all the tools or softwares that are there, and this project actually provides this translation or conversion between those different models, and so the model itself can be also used for archiving of the project. And maybe next time, in a few years, when you will use your own data, you won't have any more access to the software used previously. And if you use this tool, you can then have all the files organized so that you can use any other software you want. There is another very important principle in related to the files, and on the level of files, it's like, even I mentioned I'm working in a data archive, so we often encounter the problem that we receive data, and we receive also maybe some reports that the researchers produce out of this data, and then actually we are doing some checking, and often it occurs that we cannot generate the same like frequencies for some variables in the survey as they are published, and then the researchers go back and think about this, and then report, okay, I used the other files that, no, not the one that was sent, and usually people are working on the project, many people, and so it's actually a terrible situation when they don't know which is the final file version that all should use when producing some results. So this is only one aspect of this, why it's good for versioning. And so it's actually it's again, it's a good practice that each of the data set, the files that you use have like some version number. It's time-stamped, something that actually apply to a kind of identity of this file, and that it has a persistent identifier. We will talk about persistent identifiers more in the next lecture, but just that you know that this is something that is also, when you publish the data, or if you use the data that is stored in the data archives or repositories, you often see that there are different versions of files, and they are related to this persistent identifier, so that you can cite them, and that other people then know which version you used. So there are different solutions for your daily work when you are doing with data files and different files in the project. There is often a mess, and but some people also use like a GitHub. GitHub is something where you can actually store the files and describe them. And many of the repository software, if you want later to share those files, are already able to integrate with this GitHub. So it's like you only need to keep the files in order for yourself while you are still or while the project is still ongoing, but later on you can then send all those files in one step to the repository and publish them, and add some additional descriptions maybe. So it's one of the question is, we mentioned this timestamp concept, and something that is actually very close to this timestamp is that you actually keep order of your files by actually checking the integrity. So are the files are they containing the content that you expect to be containing? It can be like maybe in the digital world, sometimes files just doesn't. I mean, they can alter, or something happen to them, not intentionally, but also when you intentionally do something to the files, it's always good to keep track of this, as we mentioned, for this versioning concept. So there are some checksum tools that maybe demonstrate and clarify the concept of this identity in the digital context. And with those tools, you can actually check if there is something change on this created digital fingerprint of a file besides the name, because the name is only a label, but the content can be actually also checked. And it allows you, if there are any changes in the file, so that you will maybe need to establish a new version of, or maybe not a new version, but just a new edition of the file, because something you did in the file. So I hope you are happy up to now, and we are now having a few minutes for an exercise. So I would suggest there's some. Okay, I'm checking what is in the chat, but I'm publishing here this link to the checksum tool, and the exercise actually asks you to open this tool and then just browse using this tool on your computer and select an arbitrary file that you can then maybe edit a bit and save again. And for this particular file, you just calculate the checksums by using this button, and then you store one of the numbers that will be generated there of digital fingerprint. Store this value, and then again, using the file you used previously, you make a minor change, maybe just add a space somewhere in a text file or something, and then repeat the same sequences of from 2 to 4, and then you report what you actually find by using this. I think it's interesting to see how things really works. So please, I allow you 2-3 minutes maybe to do something, and I will check the chat when the answers will already arrive. So you can also ask some questions now. Well, you can use any files because you won't share this I mean, probably not, but anyway, maybe you can really just maybe make a file just for this purpose with minimal content. So how is it going? Going well?
Well, I couldn't really find any like really big differences in the calculation. Checksums.
No?
No,
The same? Exactly the same?
I don't know if it's exactly the same.
Yeah, because maybe you should, when you are making the versions of files, usually you have file names, and then with this there are checksums, and then there is another file. It's not usually it won't be the same file name. It will be another one. But in case if the content of those files would be equal, then the checksums would be equal. But you can have the same file name, but the content changes, then the checksums should also be different. I don't know. Maybe you didn't change the content, but it's good to keep track of exact this series of numbers and characters that are in the checksum result.
I just changed the format.
Something happened, but what? Don't know. Well, if you change the file name, no, if you change the content of the file, then the checksum should also change. So this is a test, actually, that something was then happening with the file in between the first and the second attempt. Okay, you can keep trying maybe, and follow also the continuation of the lecture, because now there we can say this is the second part of the lecture. We talked about the files and file names and things related to this, but now we will go inside the files. What's this, like we can say, unit level data organization? And for start, we will address the qualitative data. And there is an example of what should be, or what is good practice, that when you, for example, if you make a transcript of an interview, one like good practice and advice is that each interview text of the interview, so it's usually the interviews are the transcripts are in different files, and they should be then systematically named by the same project name, and then the interview number, and you can keep the table of those interviews and checksums and so on. So just to mention what we already discussed, but then you can put in this table also those information about when was the interview done, who interviewed, the pseudonym of an interviewee, occupation or age and gender, or some other important characteristic by which you maybe characterize the small number usually of people who are in a sample for that you are conducting interviews with them. But it's good that you include this information also in the interview head, so in the file that you are where you are writing the transcripts. And so there is also, like, we can mention this pseudonym concept, which is also often used in interview transcripts. So you can replace on a name of and surname of interviewee with some pseudonym, and then use this pseudonym further on. And here the interviewer asks the question, there should be a separate line then, and with the content of what was the reply to this question. And this is just maybe to specify or identify certain elements of, for example, of the transcript, as an example of the qualitative data. Then we also have in the quantitative files, we also have maybe even more elaborated structure that we want to keep there of the variables. And here again, maybe in the overall idea of fairness, we can mention that this is about how to establish links and relationships among objects in a study. So if the variables are one of the objects in a study or in the interview, if the interviewee is one of the objects, then you can establish different, relations if you keep the identity of this object, and if you are explicit with signing the relation. So this might sound complicated, but we will see some examples here, and then probably it won't be so complicated. So here you can see what is in, for example, in the many of the files, you have these identification variables. So these are not variables that are strictly having some information about some features of the units, but they actually serve different purpose. Like in CESU files, in labor force surveys, these, like censuses and also labor force survey projects, they actually inside those projects you interview, you visit and interview all of the household members. So you need to have an identifier for household, and these are different examples here. And then you can have an identifier for the dwelling, like this is again from the census from Slovenia. And then you have, then this is example for IPUMS file, person number identifier. And this one, the identifier of a record, a line in the data file, this is necessary that this is a unique number in the file. So it doesn't, it shouldn't repeat. It has to be unique, and you can check then if the file maybe contain duplicates. You can check if those are present there, and then you get rid of duplicates. And also by having the identifier of household and identifier of individual, then you can actually relate information from the household level to the individual. If you maybe aggregate some information on the household level, or maybe you have different information from family and so on. So this information can be then used by referring it through the household identifier. There is even one more complicated example, because probably many of you are familiar with those European projects, survey projects. One of them is SHARE, which it's actually social and health status of older people in Europe, and it contains different information, health information, and social family networks. It's a panel survey in a sense that the same people are visited in the interval of few years, and then you need to keep track of this information. So you can see that in this context, the ID of respondent is even more important, so that you keep the variables, maybe something changes in the two waves, but you keep the information, and you can then on the level of individual, and then you can check what changes. And I mean, it's this identification variables, they can identify also the situation of the interviewing. Like we know that in these times we often we need to use different modes of interviewing, because not all the people, for example, has access to internet, so not everyone can do the computer and web surveying answering, and then it's good that you have actually information about the mode which you collected information, because sometimes this can also affect the quality of the information that you collected. And here again we have an exercise. This is just an example of an exercise how you can use those IDs on the level of household and the level of individual. Like it's an exercise when they try to calculate what is the if the couples, like maybe women and men in the couple, if they have different employment patterns when the child is in the household, maybe women will use part-time or maybe temporary unemployed and so on. So you can check maybe even in different countries if this the same pattern, and probably is not. So how to do it? You in the actually in the file of the labor force survey, this is again labor force survey file, you have this household sequence number, and you have an identifier for a spouse, a partner of someone. So there, for this individual, you see that the spouse is in this number, and we can also say this the same relation in the other way. And here is a syntax that you can use in trying to match the information, because every individual here has his own line, but you would like to analyze, you would like to make a correlation between the information of the female and male partner. So you need to change something in the structure of the file, and here is an example where you can do this. So you select for like two, maybe it's gender, and then you actually save this file for, so these are only female individuals in a file, and then you rename and because then the variables need to have the name, because this will be then joined in the same line, different names from for the female and the male partner, and then when you rename it, you can match. So you actually join the files, and you use this, as we mentioned, the household sequence number and household spouse identifier to actually to bring to the file of males the information for females and this will be in the different files, variable names. If there is any question, you should just ask. I hope you understand, and this is like as an example from the SPSS program, but you can do it in different softwares for analysis. And maybe we just mentioned that some similar like exercise you can do also in like for some other concepts, if you want to have like study this associative mating when like couples have similar or different characteristics, maybe education or some other ethnic origin or something, and you can then check what's the degree of similarity or dissimilarity. And in this exercise, for example, we can just try to identify couples, and if there is a degree of what we can try to establish or calculate the degree of homogamy. So if how much they are same, or maybe is it like that male will have higher education, or maybe female higher education, and how is it in population if this is like it's a census file from the population Slovenia, and again you can use this ID Go. It's identifier for a household. So maybe I leave you just a few seconds to think about, and then someone should maybe raise a hand and say what would be an approach, a solution. Just in maybe you describe this in which steps you would take, not in the computer code. We don't want to write a computer code right now. We don't have the file before us, but it can be an interesting exercise. If you have time, you can try to do it later. So anyone? It should be something similar that we saw in the previous example, just that now it's a bit different, the problem that we're dealing with. You should maybe also inform me if you think this is too trivial, or maybe if it's too complicated, the things I'm trying to describe here. But mainly these are just examples to actually to make you more to believe that it's really important to have organized those IDs in a file. Okay, so maybe just I don't want to speak aloud, but it's here is like again, and it's not the whole exercise here a solution, but you see it's a similar approach. So just first you produce a file with the male individuals, and then here you again produce a file with the female, and then you use certain like well the SPSS instructions how to actually join the two files based on the identifier. And here you can also rename a file from one file so that then you have two variables, like it's for like education this case. And then when you have this file as a final result, you can make a contingency table with the row with the female education in the row, and in the column you have male education, and then you can try to calculate some indicator of this homogeny. Like, for example, how many people are in a diagonal of a contingency table, and this shows this that they have similar or same characteristics. Okay, let's go on. If we extend the discussion about variables in the file, we mentioned now this IDs variables, but there are other variables, and then similar to what we talked about the files naming, also for variable namings is we can have an arbitrary consecutive number, like order in the file, and then in the label you may mention which question number was it actually used for that variable, or you may have just used the question number as a file or as a variable name, or you can have some mnemonic short names, like for example in this general social survey from US, they use a lot of these mnemonic short names for the variables, like this one, allow comments to speak, but then it's SPKCOM, and you can also have this concept of prefix, root suffix, when you like there is a variable, probably there are two different methods to calculate this variable, but both have the same prefix in the sense that this is mother occupation prestige score, and this is just an extension of this name. So again, you already from the variable names, you know what is the content, and then when you are writing your analysis code, or if you want to rearrange the variables, it's easier for you. And then also there are some further advices about the quantitative file, how to document the information that it's contained there. I mean, you all know that it's good to have this, but what is it? Why it's useful? So it's like variable level documentation. One of those good advices is that it's good that this information is in a file itself, so that it's contained in a file, and then in like names, labels, descriptions of variables, and also the values and the value labels, and maybe descriptions of the right variables and missing values, all those information, it's good to keep in the file. And actually those common softwares like SPSS or Stata and some other, they do allow you to have this information in a file. So it's like We will talk about data sharing in the next lecture, and this most of the softwares for repositories that allows you to share the data there, they can understand those common formats like SPSS and Stata. So then you don't need to keep a separate documentation, and it's the relations here are explicit in a file when there is integrated there. So anyway, it's good to keep the link to original wording of server question, and in case if there is a label, maybe it's a short label, it should contain, for example, like we previously saw, a question number, and then there is maybe a separate questionnaire with the question numbers. And then there are some maybe more advanced approaches to establish those links, like, for example, between questions and variables, and maybe also some definitions of the concepts that you can then by some tools actually annotate in a sense, so that you explicitly describe it, and that there are links to different information. And I will just show you examples of some softwares that you can use for that purpose. One, for example, is this Collectica, and it's really there are different tools inside the Collectica, the whole suite, and then there is a Dataverse data curation tool, and I happen to know that in your university you are using Dataverse, so maybe you can ask someone to install that data curation tool if it's not yet there, and this can also allow you to document the files and variables more in depth. And then there are like other tools you can use there for maybe checking the integrity of the files. It's something that British Data Service Unit produced as something that people or researchers can use before they send the files to the repository. And there are other tools as well. So just a quick look into these tools like Collectica. You can see you have all like what we saw already in an example of what you can write in the analysis software like Stata or SPSS. But here you can maybe add some information, and there are some different levels that you can address, and you also specify different other aspects. And so it's actually you can have different views, like the file view, the variable view, and quite complex information you can there enter. And well, the data curation tool, it's a more simplified version maybe, but it will also allow you to put like question text there, and like you have this is an how you can see when you are entering the information, like you have literal question, instructions of interior, post question, universe, notes, and so, and other labels you can write. And one interesting feature of those tools, for example, those data curation tool as well, is that you can group variables in groups, maybe because if you are using I mean, working on a survey file, maybe you have different chapters of the questionnaire addressing different content topic, and then you can group those files, those variables, so it's more again readable, the file, when someone else is using, or even if you yourself is using this file. I would like to conclude this series of examples of relations among variables, identifiers, and some information related to them with an example of how to establish relations for a variable to which is in a file to an external classification. And this is one example that actually is based on some files that we are storing in the data archive, and the relations are towards the statistical office of Slovenia, and they keep a server with the classifications, and this is then you can see different classifications are there. This classification server is here, and it contains more like specific classifications, not those very international, national standard. And here then you have an example from the file actually that we keep, as I said. This is again the type of the house or the building, and this variable, in this case, it already contains this ID there, and this was then a convention to actually say that this variable description of classification is in a classification server, which is kept at the statistical office, and they can have different version of this classification. So maybe in one file they use one version, in the other file another version, and maybe even as often they do, they keep some like a tool for conversion from one version to another, because maybe they add something, but sometimes you need to compare files from different periods, and then you need to kind of harmonize files. So this is again maybe it's very sophisticated, but it shows you how it's important to keep those relations with the certain classifications. So actually, regarding the data level information, which you can also put into the labels, it's something again, a good advice is that you preserve original information always when you do some recoding or deriving variables. Here, maybe we don't have so much time to go into the detail of the example, but for example, just to shortly tell you what's the idea here. Sometimes in surveys you just ask for age, but actually if you want to make this file useful for different purposes, maybe in your project you just need the age, but if you want to have this for different purposes, it's more useful if you actually ask of the date when someone was born, or even a month, even better, and then you can always from this information calculate age. But you can also have some other calculations. For example, here again, maybe someone can suggest what other derivation from the information of the when someone is born would be possible. Okay, so just it's very typical example, in a sense that often you need not an age of someone, but where he is belonging, in a sense of maybe generations. So these are, these are people who were born in the same period, who raised, who were socialized in the same period, and this can be then, separated by dates, when the period ends, when the period starts, maybe Second World War, or when the independence happened, or I don't know, when Chernobyl disaster happened, and so it's all when you have this detailed information about when someone is born, you can calculate then different derivations from, because if you only have age, then actually maybe you cannot separate in the right intervals, or in the exact way, if you want, how you want to, in your new project maybe. So here are then some other things that are, like, again, a good practice, that you, for example, regarding missing values, that you have a neural system. Maybe you use some numbers reserved and codes related to those, because if you just keep blanks in a file, then you wouldn't know, and also other people using this file won't know, what is this? Is this something that the question was skipped, or it's a refusal, or it's something else? Often it's just a condition that someone just answer one question, and this can be also explicitly then showed in the code, so we can have this. We probably already those codes, but even it's maybe interesting to know, or to apply this principle, in a sense that you that you differentiate between refusals, not knows, and other types of these missing values, because maybe sometimes you will use, like, don't know information as a substantial information in a variable, and then you will include it. But if you don't have this information, then you cannot do anything anymore. So just again, trying to finish this part of the lecture, just give you an information of that here in the file, but there is also a document with a more extended examples of some comments in the SPSS, for example, but this another document also contains the stata commands for some typical operations on the level of the data file, like how to recode missing values, renaming, and so on. Some good practice here is, like we say, that the variables we keep those that are the source, and then the derived variables, so that someone can check. It's good to also keep a code that was used there, like a syntax file for SPSS, or and then also it's good to keep an original and derived file, because sometimes you discover that in the derived file maybe there was some error when you derive this file, and then maybe you need to go back to the original and just make some different corrections. And again, there is a very advanced approach to solve the problem, that when you want to store these syntax files from different softwares, it occurs that maybe a software won't be available anymore, or some other things may happen. You may change the software you use. There is again a tool that allows you to convert and to actually to document what you did in the file, because the best documentation of your anything you do in the file is actually the code with some additional information, and that's it. So I will now mention some additional feature regarding this variable level information that you can use there. And we mentioned already this connection you can establish between variables and some external information. But there is more to add to this, because for example, it's related to those, FAIR principles when you want to enhance the interoperability. And here we are talking about using standard, for example, demographic or some other social science variables that are actually, when you're using those variables or classifications in your file, they're exactly the same as the standard demand. And then you can use those files to compare with different files, so you can actually relate this information from different, maybe different countries, different periods, and so on. So the one example is this ESSEC classification, and so actually you achieve this interoperability, which is also one of the quality criteria in the statistical context. And here, for example, you have examples of core social variables initiative from Eurostat, and there was an agreement that in most European big survey project of Eurostat, they will use like the set of variables that will be exactly the same and even operationalize the same. So the same classification, the same approach when collecting information, and then you see what are those objectives that you can also achieve by having this, because then you can actually compare even the information from different files or projects, and many other things you can achieve by this. And here is also a source for even extended set of variables that you can use not only from official statistics. And this is a survey coding project that actually allows you to actually extract questionnaires, coding frames, classifications, and so on for different concepts like industry, occupation, education, field of education, religious denominations, and so on. And then you can actually use this in your own surveys. So there are even like they are talking about ontologies, and this is something that in the FAIR principles also occur. These are actually some concept with definitions, but that are also stored somewhere in a controlled way, so that you can always refer to this information when you are using it. And now this won't sound too theoretical. Here is again an example. It's an example from a project that was stored in our data archive, but there was a researcher, lady researcher from Italy, that actually tried to harmonize documents from different regional archives that contains some tables about workers, female, male workers in the regions, and the border there changed several times because it's a border with a region with Italy, and you know, in the last century, it's changed many times, and then the researcher actually asked, because it was a project financed by EU, to have some advice about how to achieve this FAIR criteria. And actually, by using some concept there, it's also the files were easily to organize and variables between them, because they contain different classifications, different names for the same cities or municipalities. And so we advise is that they use geonames, which actually has some identifier of the certain location, but not in particular language or different in particular what was used in different periods. And then also we advise to use this HISCO classification, which is again another project that that people actually provide, because ISCO it's a common classification that is used for occupation codings, but historical occupations, sometimes they are so actually not existing anymore, or so specific that they are not contained there. So we advise to use this, and the final resulting files actually contained all the information, and it was she actually transcribed the figures from the tables by using those classifications, and then it was really easy to calculate something. And again, another example of access to the classifications that you can use in surveys or some other projects, it's from Germany. I guess there is again a repository or registry, or how I would like to call it, of the different classifications. We mentioned this European socioeconomic classifications, and there is a variant with groupings and some other classifications. And what is interesting of this source is that if someone is using like European Eurostat files, like EU Silk or EU LFIS, you can find syntaxes in different languages to actually use those classifications which are there, like occupation, standard occupation classification, and then you can derive this socioeconomic groupings or classification, which is actually some there is some theory behind and some concept behind that actually brings this brings this new variable, derived variable into the your working environment. Then you can use it for analysis. There are different variants of these derived variables based on different standard classifications. And here's just an example, or an expert, because this is a long file, but then it's actually finally it uses those different variables to actually derive this ESSEC, which is kind of class classification based on different characteristics of different occupations. And then there is a large code here contained that actually derive this classification finally. So we then conclude with this topic, and we just now run into the final topic of today's lecture, which is actually about anonymization. So I promised to also mention this anonymization as actually also one of the things that you do in your files, or when you are managing or transforming data. The anonymization is one of the process that you might use. And here I won't go into much details of this fair and ethical and preservation. We say that preservation and then fair principles are not the same, but again, also anonymization is not directly related to fair, but in a sense of documenting what you do, it's important to actually document your anonymization practices, and then it's also something that you need to decide whether to actually anonymize data, or maybe you will need to keep the information and maybe use some other ways to share data in the controlled environment, so not to actually to break some maybe law or even ethical principles when you are if you share the information of individuals that can harm or somehow else is not advisable. So probably you know something about anonymizations already, and I will here repeat just some general principles and concepts. So when you are doing anonymization, there you need to differentiate like direct identifiers and indirect identifiers. So it's always good to know what are the indirect identifiers, because those are those that are most tricky. I mean, it's always easy to identify the direct identifiers, but I mean, the combination of some other characteristics like occupation, age, and especially location can also identify someone. Then you have different like concepts like pseudonymization. We saw this in the context of the qualitative file, and then anonymization is just a process that you try to ensure that the risk of identifying someone is also minimal, but it's good to know that absolute anonymization is never possible, and it's always good to keep an eye to if you also are not anonymized too much, so that the file is not very useful anymore. So that there are techniques that you can use by like removal. You just eliminate a variable, like we talked about IDs, but some IDs can be also talking to outside. For example, if you have a sample with the names, then if you use the same number for identifier in a file, it's not good. Unless you need this information, it's better to remove it and just replace it with an arbitrary ID number. Then you have like top coding, collapsing, combining, like you can recode, like age can be in 10 years intervals, for example. You can have a sampling. If you have a large file, you can make, for example, in statistical file for census is a sample of the whole population, and one of the purposes of it is also to actually minimize the identification possibility. Then you can swap, disturb, and so there are different techniques, more advanced techniques, like you can synthesize a file that has the same statistical properties, but that it's not talking to any individual anymore, and so on. So there are really some advanced topics in there, but there are some practical steps that you can use in your everyday life, like what you will do when you start anonymization. Check for the consent. We will talk about consent forms in the next lecture. But here, when you are starting anonymization, it's good to remember what you promised to your respondents regarding anonymity. And then you need to decide whether you need to categorize and information there. We mentioned already these techniques. And in equality tattoo data, these are the same techniques can be used. I mean, you can also replace exact age by some broader age categories and so on. A location, replace it with some broader, or industry, and so on. Personal names, for example, of course, they need to go out, but sometimes in the interview, someone mentioned some other personal names, not his own name. So you need to keep an eye on it, because again, maybe it's not allowed to have it in. And then there are proper names of organizations, which are also quite good identifier, even if not direct, indirect identifier. And you can always replace those. And unique locations, you can replace them by maybe some standard coding of regions or places names. Instead of them, you code just characteristics of the place, and so on. And then you enter into the anonymization plane, where you actually assess what to change, what to remove, what about occupation. Occupation can be very detailed, as we saw from previous example, and some of those categories are maybe reserved for very narrow number of people, and then someone who knows those people can actually trace them. And so it's always good to get rid out of those and maybe join them to some wider categories. So, and you can also decide what information maybe is more important and less important in your file. So then you actually use this information in deciding what to anonymize and whatnot. So here is an example you can maybe try to solve later, just of detail, and there is a content of this example referred to very sensitive topics. So here probably you will need to be very strict and radical in anonymization. And then there is also a quantitative anonymization exercise, which I invite you to actually maybe to solve it for your own, and decide about this anonymization method regarding what maybe you can also think about your own project and the file. And we can skip this solution so that you have some material for trying to solve it your own. And here, for conclusion, I just mentioned some softwares that can be used. This can be quite complex softwares, or there are maybe different, maybe more simplified softwares, so that you know that you can use those. But it's always it's very time consuming to learn these softwares, and sometimes those simple techniques that to be mentioned, they suffice for your project. And also for just the last thought, what I would like to share with you is that maybe the anonymization and the identification is not necessary. It's not always necessary, in a sense that, as we mentioned, that maybe the usability of the files would be too much reduced, and then you can share this in different, maybe uncontrolled way, or maybe if there are public information contained. I mean, if there are known persons, elites, sometimes you don't need to anonymize because this is public information already. And sometimes it's also you need to decide what and when to identify. I mean, a small village and so on. This is something that it can identify people, but again, is this really very sensitive information? Is it needed to be very radical? And often it's not. So this is just my final message to you. So thank you for today.